pentose phosphate pathway. Happens in the cytosol of all cells. Its purpose is to make ribose 5-phosphate and NADPH. It's a pretty simple, shorter unit. I would recommend from the beginning just writing out this pathway over and over again. So the first part is the oxidative phase. That starts with glucose 6-phosphate, and of course that comes from just glucose through the glycolysis steps. And then it takes a different route. Another enzyme comes in called glucose 6-phosphate dehydrogenase. All dehydrogenases are niacin B3 dependent, and you can know that because they make NADPH in the PPP here. So NADPH is made in steps 1 and 3. This middle step nobody really cares about. I can't even pronounce it. Phosphogluco, some letter lactone by lactonase. And you have another dehydrogenase 6-phosphogluconate dehydrogenase. So another B3 dependent. That's where your other NADPH comes from. The product of these first 3 steps is ribulose 5-phosphate. I know he said this in class, but when you see rib written out, it's ribulose. If you see just R, for instance R5-phosphate, that's ribose. Make sure to keep those two straight. So after the oxidative phase, you have the non-oxidative phase. So this oxidative phase will happen several times, and so you have several ribulose 5-phosphates. And from that ribulose 5-phosphate, you can make 2 things. You can make ribose 5-phosphate or xylulose 5-phosphate. The enzymes sound very similar. They're both phosphopentose, but to make ribulose into ribose, it's isomerase, and to make ribulose into xylulose, it's epimerase. This into xylulose is actually going to happen 2 times here, so there's another xylulose 5-phosphate, but we'll talk about that in a second. So the ribose 5-phosphate and xylulose 5-phosphate react with transketolase, and that makes GAP or G3P, same thing, plus a 7-carbon cetohepulose 7-phosphate. Keep in mind that transketolase is TPP dependent, that's thiamine, or B1. And then the products of that reaction react together with transaldolase. And transaldolase makes fructose 6-phosphate and this here. I stutter on that because I have no idea how to pronounce it. Erythrulose, something like that, 4-phosphate. I just abbreviate it ERY. Alright, so you should recognize the fructose 6-phosphate. That's its own separate thing at this point. That's going to go off to glycolysis or something. We'll talk about that when we get to the modes. And the erythrulose is going to react with this other xylulose. So you have another xylulose 5-phosphate coming in. Those are going to react with transketolase, its second reaction, same enzyme, to get another fructose 6-phosphate and another GAP or G3P. which are both glycolysis metabolites. So this pathway is highly integrated or highly linked with glycolysis. So that's the pathway to memorize. It's most of the work right there. The pathway is going to act differently depending on the needs of the cell. So don't forget the glycolysis and the PPP are very intertwined. So that's what you're going to see here in the modes. So for the first mode you need ribose 5-phosphate. In order to get that, there's no oxidative phase here at all. You have your first couple steps of glycolysis happening here, except you're taking the fructose 6-phosphate and GAP and turning them into the ribose 5-phosphate. So this is your goal. These are the enzymes. You know, there are a couple steps that we had just talked about in the pathway itself. Remember, when you're in this pathway, it's not just coming down as it's kind of drawn out here. All these enzymes are all reversible. So that's basically what's happening. You're starting here and you're going back up towards the ribose 5-phosphate. These other ones, sugar molecules are in there. They're just not drawn. But that's indicated that they're in there because there are trans-ketolase and trans-aldolase reactions. So mode 2, you need them equally, talking about ribose 5-phosphate and NADPH. So it's basically just the first part, as the whole oxidative phase happens. You get 2 NADPHs out of there. Instead of ending with the ribulose 5-phosphate, you do the very first step of the non-oxidative phase, which turns it into ribose 5-phosphate via phosphopentose isomerase. So you're getting your NADPH, ribose 5-phosphate, and that's it. So that one's nice and easy. Mode 3 is the most common. You need NADPH. So what's happening is the goal is for this oxidative phase to happen as much as possible, because the oxidative phase is what generates the NADPH. So you have these glycolysis metabolites, except this time they're going up towards the glucose 6-phosphate. The whole goal is to get that glucose 6-phosphate so you can take it to the oxidative phase. That's generating the NADPH that you need, and then you basically take the ribulose and recycle it. So it keeps going in this, so you keep generating the NADPH. Mode 4 is exactly the same, except for one slight difference. So you need NADPH and ATP. So if we were going to turn this into mode 4, everything would stay the same except this gap goes through glycolysis, and eventually you get pyruvate, and eventually you get ATP. So rather than the gap going back up, the same thing is happening, except some of the gap comes down to turn into ATP, so you get a balance of ATP and NADPH. So no need to relearn mode 4. If you know mode 3, just circle gap, draw an arrow down, and know that you get ATP out of it. After that, in the notes, there are a couple slides that say the uses of ribose 5-phosphate and NADPH. Know those slides, that always comes up in the questions. The regulation is the easiest out of any unit. The very first enzyme we talked about, the glucose 6-phosphate dehydrogenase, is the one that is regulated, the only enzyme in here that's regulated. And if you have low NADPH, you're going to go through the PPP because that's a product that you get more of it. If you have high NADPH, you don't need any more, so that's going to inhibit this enzyme. And that's all for regulation. And then there's a bunch of random stuff at the end. The things that come up on questions are that fava beans are one of the ingredients of certain types of falafel, have this davincine, and that can generate organic peroxides. Same with pamaquine, probably butchering the pronunciation of everything I pronounce here. That was the anti-malaria drug. So you get these organic peroxides which can oxidize your DNA, basically acting like free radicals. And to get rid of them, you have glutathione. So this glutathione here is in its reduced form. So the reduced form is going to neutralize that organic peroxide. So it's the oxidized form over here. Glutathione peroxidase is the enzyme that catalyzes that reaction to get rid of these dangerous free radicals. And then you have these oxidized glutathiones here. So that's where NADPH comes in and turns the oxidized glutathione back into reduced glutathione, so this can go back and continue fighting off free radicals. So that's the importance of NADPH as an antioxidant here. Glutathione reductase is the enzyme that catalyzes that reaction. Remember, that's selenium in the enzyme from Unit 6. While we're talking about the reactions to know, the other one to know is the elimination of xenobiotics. Xenobiotics is abbreviated as RH. So that's another one that has NADPH being used to eliminate it into a more neutral, safe form. And the enzyme for that is cytochrome P450 reductase, which has iron sulfur attached to it. The very last thing is the clinical. Know that Heinz bodies are from a glutathione shortage. That's its reduced form. And that can be caused by not having enough NADPH. So if you don't have that, something happens with the cysteine molecules in the hemoglobin of red blood cells, and you have these bodies build up, Heinz bodies. So you should be able to associate all of these things together. Wernicke-Korsakoff syndrome is the last thing. Know that has to do with transketolase, or TK. TK basically has a lower affinity for TPP, so people need a lot more thiamine, which isn't a problem unless they have a high alcohol intake, and alcohol interferes with that. So, short and sweet unit. Double check if there's anything else. That's it. Good luck.